Bismillahirrahmanirrahim. Assalamu alaikum. We are doing volume and surface area of 3D figures. In the last session, we discussed cuboid, calculated volume of the cuboid and the surface area of the cuboid. And while calculating the surface area of the cuboid, I showed you net of the cuboid, like a cuboid cut out from the cardboard, and with that help we were able to understand the number of the faces the cuboid has and what are the dimensions of the faces of the cuboid. And it was pretty helpful in understanding how to calculate the surface area. So now we are going to discuss a cube. Here we have a cube, and again I have a cube made from a cardboard, and this will be helpful in understanding the cube. So in case of the cube, the length, breadth and the height all are equal. In the cuboid it was different, right? In this case all the sides are equal. Okay, so if all the sides are equal, we have to calculate the volume of the cube. So in case of the cuboid, what we did, length into breadth length into breadth into height. Now in this case, length, breadth, in the case of the cube, length is equal to breadth is equal to height. All are equal. Okay? So what is it? If this is L, this is L, this is L, so I'm going to use L cube. L into L into L, right? So L here is 2. So 2 cube, which is 8, right? 2 into 2 is 4, 4 into 2 is 8 centimeter cube. So this is the volume of the cube. Now coming to the surface area of this same cube. For the surface area, now this is the net for the cube. What I mean by the net, when I unfold a cube, I get something like this. You see, this is the cube I have, again made from a cardboard, and when I unfold this cube, what I get a net like this. Okay, so what is happening here? I have here 1, 2, 3, 4, 5, 6 squares, right? I have 6 squares and the dimension of each square is equal. So if the dimension of one square is 2 into 2, okay, so that is L square. Length into length is L square. But how many squares I have? 6 squares. So for the surface area of the cube, is equal to 6 squares, and for the square, like for the area of a square is length into length, L square. So we have 6 squares and area for each square is L square. So L square. So by this we will get the surface area of the entire cube, because these are the 6 faces. Okay, and if I calculate the area of each, see, this is my cube, and when I unfolded it, I got 6 squares, and all the squares are equal. That is why I said 6 squares, and area of each square is L square. So what am I going to get here? 6 into 2 square, which is 6 into 4, and it is 24 centimeter square. Got it? So it's pretty simple, right? So now it's time to move towards a prism. I'm going to take a prism which is in a triangular in shape, obviously, the simple prism. So let's discuss that. Okay, now we are going to discuss a prism. As I have drawn a prism over here, and I have a prism here. You might have seen this prism in your physics lab. This is a prism, right? And what I have drawn is something like this, right? This is prism. So, what is a prism? How do we define a prism? A prism has a uniform polygonal cross section. Now, what does this mathematical definition mean? It means that if I am holding a prism like this, right? You see, like this. And I am going to cut this prism, right? I am going to slice this prism. So I am going to get a uniform slices of this prism. And these uniform slices are the uniform cross section, right? That means that each and every slice is going to be a triangle and of a same dimensions. Like this triangle, every slice is going to be a triangle with the same dimensions, right? It's just like that. If you keep in mind a bread which you buy from any bakery, and if you take it out from the bag, and you will see that each and every slice has almost the same dimension. I mean, it's okay, it's a bread and it might have a little bit different, but approximately each and every slice has the same dimensions. In the same way, if I am cutting this, if I am slicing this prism, each and every slice, that is a cross section, and that cross section is going to have some shape, and that is why it is said that it's a uniform polygonal cross section. Because it's a triangle, so it's a polygon. The polygon is a figure having 3 or more sides. In this case, it's a triangular prism, so every slice is going to be a triangle, right? So this is the prism. Now, if we have this prism, it has this side and this side are equal, and this base is little more than the 2 sides. And it has a height as well, like this. If we are holding it like this, it has a height which is of 4 centimeters, right? Now we have to calculate the volume of this prism. So what it is going to be? So for the volume of the prism, so what are we first we are going to consider this face, like this face. Okay, we are holding a prism, we are going to consider this face, and then as I was saying that if I am slicing, I am going like this direction. First we will consider this face, and then this thing will be its height, right? If I am holding it like this is the height of the prism, and this is the polygonal cross section. And if we can say it a cross section, or we can say a base. This is the base of this prism, and if this is the base, I'm going to say I need the base area. Okay, I need this base area, and once I have this base area, I'm going to multiply with this height, right? This way. I need the base area. I'm taking this triangle as a base. and there are two bases, right? This is the base, this is the base, right? Two bases, and then into height. So that way I'll get so first thing, let's calculate the base area. The triangle which we have, the base area. So base area into height. Or you can say this base area, you can name it as a cross section. Area of a cross section into the distance between the cross sectional bases, right? So the base area is half, which it's a triangle, so half into base, which is 6, into height, which is 4, okay, into, now we have taken this as in the case of the cuboid and the cube, we use the third dimension of height, and in this prism we have a height as well, right? If we are holding it like this, it's a height, okay? I have taken this area of this triangle, but now I need this height, okay? And this height is 15. So in this case it becomes 12 into 15, so which is 180 centimeter cube, okay? So for the volume, what we have to consider, no matter what type of prism is it, we have to first understand what is the base or the cross-sectional area of that prism. Once we understand that cross-section, the cross-section is that area. If we keep on slicing that prism, we are going to get the same polygonal shape, right? So in this case it was this triangle, and if we have this triangle, we are going to get the area of this base, and then we will multiply with the height, whatever the height the prism has. So base area into height. So we have calculated the area of the triangle into the height, and we got our volume of this prism. Okay, now let's move towards the surface area of the prism. For the surface area, now, to calculate the surface area, first we need to know how many faces it has, okay? Once we know the faces, it will be easy for us to calculate the surface area. Okay, now if you see this, while calculating the volume, we said that this is the base, okay? We can say this, if this is the base, the same kind of triangle is at the back as well, right? For the volume, I was not interested in how many bases, how many sides it has, but I was interested in just the base area. But in case of surface area, I'm interested in both the sides. If this is the front triangle, on the back I have the same triangle as well, right? This one triangle, this is second triangle. So I have two triangles which I used as the base area. So I have these two triangles, right? Same type of two triangles. And if I know the dimensions of these two triangles, if I know this, if this is 5, this is 5, this is 6, okay? So what is the perimeter of this triangle? 5 plus 5, 10, and then 6, 16, right? So 16, the perimeter of this triangle is 16, and as we calculated, the height is 15 in this case, right? So it means that if I am going to unfold this, suppose I have this thing here, the prism I have made from a cardboard, right? Same type of a prism. The base is triangular. The base is triangular. Now I am going to unfold it, okay? I am unfolding this prism. So what is happening? I am going to get 3 rectangles and 2 triangles, right? You see, when I was talking about the base of the prism, I said if I know the perimeter of this base, which was, I said, 5 plus 5 plus 6, right? So it was giving me 1 dimension for that rectangle when I unfold it. It was giving me the breadth for each rectangle. So see, 5, 5 and 6. So the 1, 5, this rectangle gets, 1, 5 this rectangle gets, and this was 6, this rectangle gets this. So, okay, so perimeter was, I'm using the perimeter 5, 5, 6, and these are 3 rectangles. Okay, now, so making the thing simpler, for the surface area, okay, I need the area of this rectangle, this rectangle, this rectangle. So I have 3 rectangles, 1, 2 and 3, and I have 1 and 2 triangles, right? So I need to calculate the area of these 3 rectangles. And in this case, what is happening? 15, the length, the height is now converted into the length of the rectangle, 15, 15, 15, 15, right? And you see why I was talking about the perimeter, because the sides. One side of this is 5, 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 this is 5. And the base was 6, so this is 6, this is 6. Okay? So too many numbers, so just removing some numbers so the things look simpler. Okay? So 3 rectangles. So surface area So I have 3 rectangles with the same, okay, dimension. 2 have a same dimension and 1 has a breadth little more. So what I am going to do, 15 into 5 plus 15 into 5 plus 15 into 6, right? So all the rectangles are covered. 15 into 5, this. 15 into 6, this. 15 into 5, this. I have covered all the 3 rectangles. Now, plus I need the area of these 2 triangles. See this. So I have 2 triangles with this. So I can do like this: 2 into half into the height for this triangle was 4 and the base is 6, right? This 2 goes with this 2. Now what I'm going to have here, so 15 into 5 is 75 plus 75 plus 90 plus 24. Okay, so it's 150 plus 114. I hope I have calculated it correctly. Okay, so it is 264 cm square. Okay, so I have calculated by unfolding it. Now there is another way of calculating the same thing also. Surface area is equal to, now I was talking about the perimeter. So perimeter into height plus 2 into base areas. There are two bases, okay? So how are we going to do this? Parameter 5 plus 5 plus 6. 5 plus 5 plus 6 into 15 plus 2 into half into 4 into 6, okay? So what we have here, 16 into 15 plus 24 and 240 plus 24 is 264 cm square. Now this is a proper formula, parameter into height into 2 into base areas, because each prism is going to have two faces, first front face, back face. That is why we are saying 2 base areas, right? And then the parameter into height. Why? Because I have shown you by unfolding this thing. 1, 2, 3. It gives you 3 rectangles. And for the rectangles, the height gives you the length and the sides of the triangle gives you the breadth. So I have calculated the both ways to give you the idea how the surface area is calculated. Hope you got the idea and you understand what I have said. So thank you very much for now. Give me feedback, especially regarding the surface area of the prism. If I get some feedback, we can improve the things. Okay, Allah Hafiz.